All right, so now we are getting into the actual program, and it is my pleasure to welcome Felix Naumann, who is visiting us in these few months. Felix is going to talk about data quality practices in the age of AI. So you know, your research interest coming through that word cloud, and the very essence of the information resilience put together into one title. Now, Felix is a renowned global leader in data management. He did his PhD from Humboldt, and then went on to do a postdoc at IBM Almaden. And then a few years later, he's been at the HBI Institute in Potsdam, Germany. He has been working in a variety of leadership roles, including being the editor-in-chief for the ACM Journal for Data and Information Quality. Has written over 250 pages papers on a number of really important topics like data profiling, data quality, and so on. And we are really delighted that Felix is spending his sabbatical with us here at CIRES and is, here and available to give this talk. And some of you might remember that actually Felix was here also in our very first PhD school. Who remembers that? Yeah. Those ones who are back. Yes.
Thank
excellent. All right, Felix, okay, cool. Over to you. Great. Please join me in welcoming.
So a PhD student of mine found this on the subway in Berlin yesterday, actually, so I thought I'd include it. One point I wanted to make, so thank you very much for having me, Shazia, and the whole CIRES PhD school. That means really my pleasure to be here. I'm here for half a year, so I'm looking forward, I'm just here after 1 month or so I'm really looking forward to all the interactions we might be having in the future. Somehow Shazia or Kath or somebody snuck in the word practices into my title. So I think the original title was Data Quality in the Age of AI. So I'm not sure if I'll talk about the actual practices, but I'll talk about challenges, problems, and maybe look towards some solutions. Okay, so just to lower your expectations, not like you come out with a toolkit to solve all your data quality problems. So I'm, and as you can see, this is, I'll be presenting joint work with a whole bunch of PhD students and collaborators, and we've been working in this field of data quality, I'm going to say for 25 years or so, or I have at least. But of course, and obviously, in recent times, this has become more and more important in the age of AI. Just one quick word about where I come from. So the Hasso Plattner Institute is a teaching and research institute at the University of Potsdam. Potsdam neighbors Berlin, so literally I can see Berlin from my office. We're really in the center of Germany. Hasso Plattner is the co-founder and long-yeared CEO of SAP. Not everybody knows SAP, but it is Europe's largest company altogether, and Hasso Plattner is something like Germany's Bill Gates, and so he's funding this entire institute, which is of course great. We do bachelor, master, PhD programs, and research just like any university institute. So we just saw this picture. I was a little bit, I was confused on which year is which, but you can see in 2022 data quality was still a big item, right? So you can see it right here, and it kind of vanished over time, apparently. Clearly we've solved all the data quality problems, and now we're on to new topics, yes? And I'll try to convince you otherwise, and deep in your heart, I think you all know data quality is still a really, really important worry, and then also research area. Okay. So to introduce this whole notion, I think it's important to again emphasize this importance of data. So some of you might know Jim Gray. He's a Turing Award winner and one of the, let's say, grandfathers, I think I'm allowed to say grandfather, of database systems. He passed away, so I think he's old enough to say this, and he put together these 4 paradigms of science and explained them, and I think this is a very good notion. It basically tells us, science in the very, very beginning was very empirical. People went out and did measurements, and by the way, one of the persons who did a lot of measurements and empirical research is Alexander von Humboldt. He's also the founder of the university where I did my PhD. So he went, let's say, to South America and recorded tide charts and all these kind of things, just empirical science. Then came along theoretical science, trying to find models that explain nature, right? So here we have Albert Einstein and others, and Newton maybe, right? And then comes along computers, and suddenly we're in this computational paradigm of science where we can do simulations, large-scale simulations of weather and currents, et cetera, et cetera. So we don't really need models, we just simulate what will happen, and then we say, okay, that's what's going to happen and hope it's true, without actually having a model, right? Just running a computer. And now, of course, we have data-intensive sciences. This is kind of the age where we're in at the moment, where we don't rely on models. We build new models that we can't explain from data. And of course, somebody also came along and said, actually, we're already beyond data-intensive sciences. This was this area of big data, and now we're in intelligence-driven and knowledge-centric paradigm of science. But the word intelligence, the word knowledge also, of course, includes data. So data is still obviously very, very important for all of us. So this is from long ago, an example of poor data quality, right? So 5 of us in my group visited VLDB 2009. What is the problem with this picture here? I mean, the picture is fine, but what's the problem with the data on this picture?
Color and quality.
Huh?
Color and quality.
Color and quality, okay, yeah, true. That's not what I'm after. The affiliations. So we're all from the same institute, the same university, but we have 5 different affiliations, right? So, it's not a big deal, but as soon as you want to start doing statistics of from whom, where are our attendees coming from, you'll have a problem because you won't realize that these are all actually from the same institute. Let me show you some other examples. So Wikipedia, big, important information source. Obviously, there's lots of vandalism going on there of some, obvious kind. So Rob Ford is a famous mayor of Toronto whose prior experience is this, right? And who left office inebriated. Okay, this is all fun and games. But actually, this is a little bit worse. This is some of the vandalism we discovered, which leads to poor data quality. This is somebody editing Wikipedia to change the racial makeup of their community to prove some point, right? Probably that person was trying to say, look, we're being overrun by Hispanics, right? And just making up data to prove some point. This is really important topic and really bad data quality. Let's say a more common, typical situation that we have when we work with companies is something like this, a little bit difficult to understand. This is a database schema, right? And I guess you've all can imagine a database where you have fields for name 1, name 2, name 3. I mean, obviously very poor schema design, but this is how schemas look. And you have city and district and street, etc., right? And what people do when they fill in this database is they hide value in wrong fields, right? So for instance, this district field, nobody really needs the district, right? City and zip code is enough. The district doesn't matter whether you're in Fortitude Valley or in South Brisbane or whatever. So people put stuff in there. They put the mobile phone number into the district field, right? Or even worse, they put a deletion flag or an embargo flag in there. Does anybody know what that would mean to put the deletion flag into a district? What does that mean? It means to type in the word "do not deliver!" exclamation mark, exclamation mark, exclamation mark. So whoever pulls out that record knows that customer does not pay their bills, so we shouldn't be delivering something to that. And they just put it into the database because they have no other place to put it. But as soon as you send out Christmas cards, it gets quite embarrassing because on the address field, you'll have the first name, last name, and then just a big "do not deliver" on the address field so the customer knows you don't like him. So these are interesting examples. I'll skip this one here and get back to what Shazia was telling us about the C-suite, all the different people involved in data science and AI. This is how I like to show it, kind of like a pipeline. And then I also like to try to distinguish data engineering from data science because we're more of an engineering school. We want to show people that you don't need to be data scientists to do something interesting. Data engineering is also super important, right? And this is the area where we'll be spending the next, 30 minutes or so in this area of extracting and curating data. This is where data quality plays the most important role. Okay, that being said, you're very welcome to ask questions in between. I mean, I can just go on rambling and rambling, but if you have questions or comments, absolutely speak up. I'll promise I'll stop in time, and I'll just be skipping some slides if we need more time for discussion, right? So do interrupt me if you have anything to say. Great. Okay, so big motivation. This is a typical study. So who's seen this chart? This is a very typical chart. Okay, good. So this is rather old. It's from 2016, but I've actually looked it up recently, and it's still true. This was a questionnaire asking what data scientists spend their most time doing. Data scientists, right? And as you can see, 60% of their time, they said, they're spending in cleaning and organizing data, right? And then another almost 20%, it's about collecting data sets, right? And only the rest is really data science-y stuff, like building models, building training sets, refining algorithms. So we train data scientists, but what they do is data engineering all day, right? And then not surprisingly, what is the least enjoyable part of data science? The same people were asked, and it's exactly the same distribution. Cleaning and organizing data and collecting data sets is also the least enjoyable part of their job. And I guess you all know, as being researchers, I'm assuming you kind of agree to this, right? So I'm sure all of you have spent time, getting a CSV file and spending hours and fixing it and finding errors in it and trying to load it somewhere and it doesn't work, all this stuff, right? And this is one symptom of poor data quality. Already at the, let's say, file structure level, no matter whether there are actual errors in the data, you won't recognize that while collecting the data sets, but then later on you will have to be cleaning them, right? Okay, so this is my motivation. So I will go through these 4 points. I'll tell you a little bit of background in data and information quality research. I'll talk about data preparation, so the first step of data cleaning. Then I'll move on to a little bit more advanced things in AI systems. And then my pet project that I'm trying to push also here is data quality assessment. So how do we even measure data quality? Because as we all know, you cannot improve what you cannot measure, right? Okay, good. Here's a nice quote of a very, very good book, Zen and the Art of Motorcycle Maintenance. In case you've never heard of it, I really recommend reading it. Robert Pirsig is a philosopher, has nothing to do with computer science, which is a relief, so you can sometimes read other books. And it's all about quality, and he says even though quality cannot be defined, you know what it is, right? And it's kind of us saying, yeah, we know data quality is a big problem, but let's do this project anyway somehow, right? But we, as computer scientists, of course, need to go a little bit further. There was seminal work many years ago, almost, really long ago, 30 years almost, by Richard Wang and others at MIT, who tried to establish what is data quality, acknowledging that it is many dimensions. They started from this general notion of fitness for use, okay, and then they did lots of surveys, etc. And then in the end, it boiled down to these kind of data quality dimensions. Data quality is made up of many different dimensions. The obvious ones to us might be things like accuracy. Is the data correct, right? Others might be, which we understand, is completeness. Is it complete, right? But there are other stranger things, like is it believable? Is it understandable, right? Is it relevant, right? So these are, especially from an information systems perspective, also, of course, important data quality criteria. They're just a little bit more difficult to handle for computer scientists, right? But it's still, it's an important part. And I would argue in this age of AI, we have to go a little bit further from what they did previously, right? So a lot of things that we've been thinking about, for instance, is the question of diversity, right? Or representativity of data, right? This was not part of the original data quality dimensions. Why? Because there was kind of an assumption, well, the data is what it is, right? But now we know it's not enough to just say it is what it is. If we want to train models on them, it has to be representative, right? We need diverse data sets, diverse labels to properly train systems. Also, what they didn't look at is things like security, or maybe even liability as a quality dimension. Who's liable for the information in there, right? Or explainability, not just of the models, also of the data, right? So adding metadata to the data. So I would say we need more AI-specific data quality dimensions. I'm not going to go ahead and define all of them now for you, but I'm just saying the old research needs to be enhanced by AI-specific things that people in 1996 did not foresee. Okay. We're proposing a new set of data quality dimensions, just a bigger set. I'm not going to go through all of them. The color code is a degree of freedom I have not used yet, so there's no meaning in the colors. It's just a nice chart, basically. But here you can see we have lots of things that we want to consider, right? So accuracy is still there, completeness is still there, but we want to think about things, as I said, like privacy, understandability, compliance maybe, the balance of the data, diversity, et cetera, right? So what I'm trying to say is these are all important data quality dimensions that have to be considered. And what we're trying to do in our research is define them and then assess them, right? So in a perfect world for me, I have a CSV file, right? I want to know its quality. I dump it into a tool, and the tool will in the end say, ooh, quality 0.85. That would be interesting, at least, right? Of course, we need to go a little bit deeper and explain these things. But a prerequisite for that is I dump the CSV file into a system, and it tells you relevance is 0.7. It tells you consistency is 0.9, things like that. So, you know, it's all nice to define to define all these quality dimensions, but how do we actually measure them? How do we make them actionable, and not just talk about them, saying, "Oh, this is all important, has to be considered." Okay, so let's start with a few simple dimensions that just talk about how the shape and form of the data. And this is a little bit of research we've been doing in the past. Data preparation, I'm sure, is a term that you've probably heard of, or you've done these things yourself. I like to define it a little bit more specialized, so I like to distinguish it from data cleaning. You'll find work that says data preparation is everything you do before you train a model, let's say an AI model, but it makes sense to distinguish a little bit and say data preparation is more about syntactic things like cleaning up the commata or the quotation marks, getting the file readable, right? And then data cleaning is more semantic, that is checking the correctness of the actual values and changing them, right? Is that phone number actually correct, rather than is it correctly formatted, okay? So data preparation is already a big hassle, right? And again, I'm sure you've all experienced this, and there's really not much research about this, but as we just saw, 60% of the time is spent on this stuff, right? And so what is wrong with this file here? So we can't really check, are all the values correct? Let's assume they're correct. What is wrong with the file? Visualization is bad, I agree. This is just a screenshot of a CSV file. I could have done a better job, but maybe I did this on purpose. Yeah?
The identification number, it repeats.
The identification number repeats. Indeed, so you can see this here. Maybe this is on purpose, right? I don't know. So nobody told you that I mean, ID sounds like it should be a key, but apparently not, yeah? But it's even worse. If you try loading this file, you'll get an error, probably, right? Why? It's very difficult to notice, I guess, yeah? But every line is preceded by a quotation mark and ended with a quotation mark, right? So there are quotes around every line, right? This happened, I don't know why, an export from Excel or something, right? It just thinks it's all one big string. And if you start importing this in a database, everything will be loaded into the first field, and you'll be wondering what went wrong, right? So simple mistake, I guess most of you could write, spend 5 minutes to write a script to clean that up, right? But this is just one of the possible mistakes, and you won't, and they're difficult to find. I'll show you something else. What's wrong with this file here, right? Looks like a nicely structured spreadsheet. It's useful data, let's load it into the database and make use of it. What's wrong with this file? Or why shouldn't you just use it as is? This is easier in this case. Headings, yeah. I mean, these are not very nice column names, I agree, in a database, but okay. Unnormalized. Any ideas? Huh? Say again? Floats? Yeah, okay, yeah. So this is not what I'm getting at. It doesn't matter, right? What I'm getting at is these aggregates here. Look at this stuff, right? Smack in the middle, line 258 is a total of all the stuff above, right? And then 259, all of these are aggregates of stuff above there. And this thing repeats again and again. It's just in the middle of the data. The data looks normal. It's also, let's say, integers or something, right? You load it, but this should not be in your database at all, right? So then the question is, because these are aggregates, right? You should be able to compute them, but they shouldn't be part of your data, right? And again, recognizing this and then cleaning it is not easy. Again, you could write a script that does this. You'll just say, oh, whenever it starts with a star, I'm going to delete those lines. Sure, you can all do that. But again, do you want to do that for every single file? No?
We're just thinking about the lights.
Yeah, I don't know.
Dim it down a little bit.
I didn't touch anything.
Yeah.
I'll just continue.
Mm-hmm.
And the last one here, I just wanted to show, this is fun, I found this, right? So this is all data, and then right in the middle, somebody put data are confidential instead of the actual value, right? Again, right, it's super annoying when you try to work with that data, right? Again, you can clean it, but you know, it's no fun, right? So data preparation is a big topic. There are plenty of tools out there that help you do this data preparation. And we did a whole bunch of projects. I'll just highlight two just to show you kind of what kind of things you could be doing in data preparation. So there's actual research in this area. It's not just about being annoyed that you have to write some scripts. We can actually, as computer scientists at least, we can actually do something about it. Let me skip this one again. I'll just show you a benchmark that we built to measure the ability of systems to ingest data. So we said, look, data has all these different strange mistakes, right? Let's test systems how good they can deal with those mistakes, right? And so we have lots of different, we identified lots of different problems in the data, in existing data, and then simulated that and just loaded it into the system, right? And so we took out a whole bunch of files from GovUK and Mendeley. These are scientific data files. And then here you can see that only a fraction of them always was standard in a way defined, let's say, by the CSV standard and being able to ingest it into a typical system. And the yellow part just shows that many of these files, just from the start, as you download them, have some problems, right? Many of them. And so we built this benchmark with lots of different pollution, so we made the data a little bit dirty, and then we measured all sorts of systems, specialized systems to read CSV files, but also databases and spreadsheets and Google Spreadsheet, et cetera, and gave them some scores, right? And my hope is, and actually this is happening at the moment, is that these vendors start picking up this benchmark and say, okay, let's improve our import processes so that we can ingest more files or more problematic files than before, right? And so this is actually happening. And again, you cannot improve what you can't measure. Now you can measure, let's say, how good is your system in automatic data preparation. Okay, so that was just one, a quick highlight. Any questions about this data preparation area? So it's really fiddling around with the bits and bytes, right? I always liken this to the situation where let's say you're at home and something is lying in the corridor and you always have to step over it every single time, right? Instead of once picking it up and putting it away, it's just easier to step over it every time, right? But the amount of time you spend stepping over something and the effort is, of course, accumulated much more than just actually cleaning the stuff up, right? Same with data preparation. Of course you can clean the file that you're working with, and of course it's going to be faster than doing proper data preparation with a tool. But accumulated, you're spending 60% of your time with this stuff instead of getting tools to do this for you. Does that make sense? Okay, good. So let's now move on to data quality problems and their problems in the context of AI. So we did it's still actually ongoing, a large study where we pollute data, we introduce errors in the data, and then we measure their effects on typical machine learning or AI models, right? So this is really a purely empirical study, right? By saying, okay, how important is consistent representation? I'll tell you what that is in a second. When you have dirty training data, are running a clustering algorithm with k-means with some data sets, right? What is the effect of that problem? Right, and so and we have this huge parameter space, lots of different kinds of pollutions, lots of different scenarios. Dirty training data, dirty test data, or both are dirty. Actually, this is a good situation because if both are dirty, then they'll one learns for the other. We do lots of runs. We have classification, clustering, and regression tasks. and a large set of data sets. So in the end, this is how our experimental tree looks like. And we're doing 5,640 experiments because it all multiplies up. This takes about 5 days or so on our big server farm. And in the end, you kind of know, or at least can observe, how data behaves. And this is one typical example. Yeah, go ahead.
What kind of pollution?
Yes. Okay.
Noise or virus or what?
Yeah. So we did this with these 5. I'll tell you in a second what they are. So this is not complete by any means, right? So we chose these 5 because in the literature we found pollution methods for those 5, right? So consistent representation is the question, do we represent the same thing in the same way? So New York, New York City, NYC, Big Apple, right? So different representations for the same thing. Would be this one here. Completeness is we just inject missing values or null values, okay? Feature accuracy is we swap values in our training features, right? Target accuracy is we swap labels, the target labels. Uniqueness is just the problem of having duplicated rows in your data, which actually happens a lot. And target class balance is maybe the one that you were looking for, where we create an imbalance, obviously by sampling. Okay, you could, there's tons of more stuff you could do. So maybe this work that I'm presenting here might be as a kind of a model of how to go about these things. Again, this is only empirical, just to see, are these effects important? And as expected, of course, we see that as the quality goes down, also the F measure of whatever you're doing goes down. So it's not really a surprise. There are some surprising findings in there about how important is it to have a clean training data, how important is it to have clean test data, these kind of things. So I'm not going to sell you with the actual results. I'm just saying this is an important foundation, at least in my mind, to see how important is data quality actually for what you're doing. And obviously it is. It's not, again, it's not surprising, but it's an establishing the ground for this kind of research. So what can we do about it? One quick project idea that we're just submitted, so let's hope it gets accepted, is, well, I have dirty data. I want to clean it, right? How do I go about cleaning it, right? This is a big problem, right? Because, let's say you have your data curator and the boss says, our model quality is not good enough, clean the data, right? So what do you do about it? Your time budget is limited or your money is limited. Where do you even start, right? And it's not obvious that you should be cleaning the obvious errors. Maybe those are not really a problem for your AI system, right? So what we do with this work is we try to recommend where should you focus your cleaning effort, right? And how do we do it? We do the following, right? Let's say we have data that is polluted. We don't know how polluted it is, but it's dirty data. It's what we have, right? So what we do is then we increase pollutions. We make it even more dirty in different dimensions, measure how good the model now behaves. So we create this line here, and then we interpolate the line to clean. So we make it dirtier to see what is the effect of making it dirtier, to then predict what is the effect of making it cleaner, and then that's what we base our recommendations on, right? And it works pretty well, right? Not perfect, but basically we're saying, okay, you should be cleaning the representation of this particular feature, right? Or you should be removing missing values from that feature, right? And then after a user does that, we retrain, and then we make the next prediction and say, okay, now, nice job. Now you should be focusing on this attribute, right? Until your budget runs out or your patience or whatever, right? This is the idea. So just to see what you can do with this kind of empirical research, you can actually turn it to your advantage. You have all these large-scale measurements, but now we can actually use them to predict not just what happens when you pollute data, but what happens when you clean data, right? And that's very useful. Okay, final questions about this? Yes?
I feel like, as per the talk, that we are making assumptions that the models expect a clean data. But what if we create models that just go around these data quality issues, that they are smart enough to handle the polluted data? Yeah,
absolutely. So first of all, there's of course some expectation of hope. so nobody actually assumes clean data. Everybody knows data is not clean. And indeed, it's not like data science and doesn't work, right? It works pretty fine, even though all data has problems, right? So first of all, indeed, there are specialized models that try to overcome these problems, but even without them, apparently problems are overcome, right? Maybe it's just an opportunity cost that we have. We could be doing better by cleaning the data. And there's this whole notion brought up, I'm going to say 3 or 4 years ago, maybe a little bit longer, and I'm getting older faster, of data-centric AI, right? So before this notion of data-centric AI, people were investing a lot in building better and better models, fine-tuning, adding layers, et cetera, or training it in a specialized way. And this is all great, right? But at least I've read papers that basically say it's more worth to spend effort in cleaning your data and keeping your old models or your old architectures rather than trying to invent new ones, because ultimately, you can play around with the architecture, but the training data, is the foundation is going to be the foundation of your model. So I would argue, again, with no real numbers or anything, it's more worth to clean your data than to try to get around it by tweaking your models, even though that research exists, and I'm sure they're doing great jobs. But as a database person, of course, I subscribe to the data-centric AI system, right? But I absolutely good that you raise it, because I don't want to sweep it under the rug at all, of course. Okay. Good. Any other comments? We have time. Okay. Great. Okay, so data quality assessment. So we want to measure data quality. And a great motivation for us was and is the EU AI Act, right? This was passed in March. Actually, there was an interesting data quality issue there as well, just as an anecdote. It was passed in March, but it wasn't published. And why was it not published? Because they accidentally voted on the wrong version of the document. and so there were lots of drafts, and everybody was rushing to add foundational models to the law and stuff like that, and generative AI. And then in the end, the actual version that the parliamentarians had was not the one that all the committees had agreed upon. And so that had to be cleaned up. And so I think in June or so it was actually then published as a PDF file in essence, right? Anyway, so this is the AI Act, which regulates how AI can be used in the EU. And this means, obviously, for companies within the EU, but also companies, let's say in the US or Australia, that sell their products or services in the EU. So it's very, very wide-reaching. In essence, all AI companies will have to, companies using AI will have to deal with this law somehow, right? And one thing that it regulates mostly is it says what level of risk does a system have, right? We have no-risk systems, which are not interesting. You have low risk, you have high risk, and you have unacceptable risk, right? So unacceptable risk are AI systems that are simply forbidden. You are not allowed to use them, right? And surprisingly, for maybe some of you, is video surveillance and facial recognition in public places is unacceptable risk. This is not allowed anywhere in the EU, right? Absolutely commonplace in the UK. I don't know about Australia. Absolutely commonplace in the US. It's just not allowed anymore in Europe, which I find is good, right? Another thing is social scoring, unacceptable risks, right? So there's lots of things that are just simply forbidden in the EU to protect the citizens, which I think is great. And all the rest of the regulation is about the high-risk systems. High-risk systems are usually those that affect a person, right? So credit scoring is a high-risk system. Any medical application, obviously, is a high-risk system. Insurance, banking, all these things are high risk. Almost everything is kind of high risk. Also, programming AI into a robot is high risk because the robot might, swing its arm and hurt a person. High risk system, right? So a lot of things are high risk. And as soon as you have a high risk system on hand, you have to abide by many of the strict regulations, and some of them talk about the training data. So how is that system trained, right? And what is great for me as a researcher is they actually talk about data quality, right? And this is the part they acknowledge high quality data plays a vital role, and not just data quality, but also good data governance and management practices, what Shazia alluded to earlier. And then they say data sets for training, validation, and testing by the way, just the latest version added validation. They earlier didn't realize that there's such a thing as validation data, okay? Including the labels should be relevant, sufficiently representative, and to the best extent possible, free of errors and complete in view of the intended purpose of the system, right? This is pretty far-reaching. It was worse earlier. So up until, I'm going to say December, they didn't have the qualifiers. They didn't say sufficiently representative, they just said representative, okay. And then they said free of errors and complete, right? And we all know there's no data set that is guaranteed to be free of errors and guaranteed to be complete, just doesn't bother. So now it's a little bit relaxed, but still, the important thing is now, first of all, this is kind of a guideline, but at the end of the day, companies that employ AI systems will have to prove to a judge that their data has these properties, right? This is important, right? Because it's very, very hard to prove, and it gives rise to all us data scientists, because we're the guys and girls who are able to tell something about the quality, right? So the CEO won't have a clue of what to tell the judge, and now suddenly we have to go about proving it. So this is my motivation for data quality assessment, right? Companies will need to be able to say how complete is the data, how representative is the data, how relevant is the data, right? To explain to a judge, ultimately, yes, we did the right thing. Okay, and then of course, appropriate statistical properties. This would be, bias prevention, diversity, etc. Good. So, as mentioned earlier, we have these 28 data quality dimensions, not just the 4 we saw on the previous slide, but of course there's more to it. And actually, let me go back. I just want to mention this. So I framed this as a legal requirement, right? But of course, also businesses themselves would like to ensure this, right? It's not like the law against the businesses. You want a good model, you want high quality data, right? So that your model that you're training is also good, right? So it's not like, there's no, the goals should align, at least in theory, right? Okay, so here we have the data science pipeline that we saw earlier, capturing data, extracting, curating, et cetera, et cetera, et cetera. And what I've tried to do here, without scientific rigor, is to align, which dimensions become important at which point in the data science pipeline, right? So when capturing the data, you have to worry about completeness and timeliness. When curating it, you're worrying about accuracy. These are just examples. When you're searching and sharing data, you're worried about the traceability of the data. So, kind of person who receives the data, trace back where does it come from, what is its origin, and then when you analyze it, let's say by building a model or so, then you're worried about fairness and consistent representation, et cetera. And then when you visualize it, it's about understandability, et cetera. So I'm just trying to place these different dimensions into the different realms of specialists who work on different parts of the project, right? Gathering the data, curating the data, et cetera, right? Again, there's no scientific rigor. Yeah, go ahead.
Added value.
Added value. This is one of the oldest data quality dimensions. This is, does the data, or the model that I trained on the data, let's say, does it add value? Does it help me? Does it add value to the business, right? So,
Does it matter to the quality?
this is an argument that we've had often. I'll just embrace it and be as complete as possible, right? So also, is privacy, how does privacy have to do with data quality, right? And also other things, let's say, recoverability. Isn't this a property of the system and not of the data? So there's been these debates. For now, I'll just keep them in there. Added value is not the focus of my research, but there's research on estimating the value of data, right, in data marketplaces, et cetera, as you know, right? You could say added value has very much to do with the context of which I use the data, but that's fine. This is true for many of these dimensions, right? Is it complete in the context that I'm interested in, right? So, yeah, you don't have to believe you don't have to believe in all of them, right? This is fine. Yeah.
What do you think would be a heuristic that you will propose to data owners that they should have before they start to utilize their data for an AI pipeline, for instance? Because data owners may want to be responsible to ensure the quality of their data, but they must know that they cannot guarantee that their data is 100% completely accurate
Yes.
in every way.
Yes.
So, and if they, and yet they also are incentivized to use their data in some way as soon as possible. So where is that fine line? What would be a heuristic for data asset owners?
Okay, so I'll give you an answer that I tell also my students is always a good answer. It depends. Yeah? Right? What is the other good answer, at least in a database lecture? So you always say it depends or for optimization. That's those two answers always work, right? Why do we do something, for optimization or it depends? So it depends. I mean, that's an honest answer, obviously. It depends on the use case, etc. So, but that's exactly kind of what I'm proposing. We're trying to assess data quality, right? Also, I'll show you later on a slide, also in the context of its use, right? So here's my data. I want to train, I don't know, an image classifier or whatever, right? Can I assess the quality of the data for that purpose? So instead of a heuristic, we'd like to, actually make concrete recommendations or concrete measurements. So I don't have a good, heuristic right away. So there's this notion of data marketplaces, right? I don't think they've really taken off, but there, of course, you could say, well, the market will take care of that question, right? So if I sell my data often, right, or if it's used often, then obviously it's of sufficient quality because people use it again and again, let's say. While if nobody touches my data, then I might have to do some cleaning, but I think that's completely unrealistic that anything of that sort will happen to the level of granularity of worrying about should I clean it or not. So the answer is not just it depends, the answer is probably no, there's probably no really good global heuristic, it just depends.
Just maybe one follow-up there.
Please.
How well will regulation be able to encode data quality standards? Like,
Yeah.
would words be able to capture
Yes.
the granularity?
Yes. So you're absolutely correct. So this is a law, and that's already the level of granularity. The law doesn't go any deeper than exactly what you just saw, right? But then, so how do companies actually go about, when they're worried, ooh, am I abiding by the law or not, right? So indeed, and we're working together with standards organizations, right? So the big European or German and European one is VDE, but these like international standards organizations. And so what they do is they create best practices or documents describing best practices to treat your data and to clean your data, et cetera, et cetera. And then if you follow those best practices, usually a judge will acknowledge if you follow the best practices, then you're not liable for problems, right? So the next step that's actually active right now is defining those best practices and standard procedures and processes to handle data. This is happening in a sense as we speak, but this is all very new ground, right? So overall regulating data is rather new anyway, right? And now we have a law, but we will have to find out how this actually pans out in standardization and in court in the end, right? And I guess the companies that will find out first are Facebook and Google and those guys, obviously. Yes.
That makes me curious. Like, out of all the existing companies and systems that you've worked with and seen data from, which one were the most beautiful?
Oh, the most beautiful.
And why do you think that was?
Ooh, that's good. It's a good question. I mean, I see beauty in problems, right? Because that's my job, right? No, I couldn't say. There's a very nice book called Beautiful Data, right? By Jeff Hammerbacher.
Or like well regulated, I guess. Yeah.
Yeah. So I have worked with a credit rating agency, the credit rating agency, actually the first in the world. It was in Germany, and they've been around for from 1890 or something. And so the German privacy law was in essence in the 80s was written for them because they were the perfect data collector about personal data. Now that didn't exist before except for the credit rating agency. They had data about every German, and they have also subsidiaries. And so they did very interesting and excellent job, in my personal view, of cleaning the data. Why? Because also in their business interest to be able to make good ratings, right? And so, I kid you not, they had factory floors, would still have, full of humans correcting data. Yeah? So I mean, literally hundreds. You look at them, and then we go in these offices and kind of try to watch them. Can we build models based on what they're doing, right? But there's a lot of background knowledge went into their personal work, right? So a typical situation there was two people marry, right? So suddenly a person has a different name and a different address, but still the same person, right? But the person married, changed their last name, and moved in with the spouse, right? So a lot of changes, recognizing that this is still the same person. So for instance, what they did is they understood the ethnicity of the last name and found it more likely that, let's say, two Turkish people marry rather than a Turkish and a German person marry. Of course, they double check and actually go and call the bank, etc. But these kind of background knowledges went in there. I'm sure nowadays, AI might be able to pick these things up, but that was, let's say, a beautiful process to me because it involved machines and human background knowledge. Yeah? To be honest, I don't know what the state is at the moment. I'm sure they've embraced AI to some degree and are now very worried about this law. Okay, go ahead.
As you shared, there are a lot of dimensions along the AI pipeline. So just a following up question. So
Sure.
maybe you're gonna set sail for your own company, but the investment you got is very limited, which can only allow you to choose one of them for your business, for your service. So which one do you think is more meaningful?
Of these dimensions?
Yes, and more profitable maybe.
Well, first of all, I would argue it's not legal to just choose one. You have to be correct and complete, et cetera, et cetera. You can't just say, I don't care about correctness as long as I'm complete. It's not legal, right? Okay. So I'll put it in a different way. And actually, I have a slide about that. Where would I put my research? What are interesting dimensions for research? If I can deflect the question in that way, maybe that's also interesting. Okay, good. So I'll continue a little bit. Yeah, we just have a few more minutes, but this is fine. Let me skip a few slides. So together with colleagues, we identified what ingredients you need for assessment, right? So you need the data itself, obviously, and this includes also metadata, etc. You need the source. You need to know where does the data come from, right? You need to know the system handling the data for things like privacy, etc., right? You need the task at hand, obviously, and also you need a human, because there are so many dimensions that are more human-centric, like understandability. Obviously, you can't assess understandability without understanding the human. And again, I've taken the liberty of kind of placing the dimensions in the approximate vicinity of where they become interesting. But every dimension, we have a big matrix, right? And say, okay, every dimension needs several of these ingredients, right? So, I mean, understandability needs a human ingredient, but it also has, let's say, a data ingredient to say, okay, is the data in the right language, let's say, right? Or is it formatted appropriately to understand it, right? So these are, in essence, guidelines of how to go about measuring. And our hope is if you have a good methods to take into account the task at hand, to take into account the source, whatever you do here will help many dimensions, or will help in the assessment of many different dimensions, right? So you don't need to start a research project for every single dimension. We're trying to generalize here a little bit with these facets. Let me also skip this slide and give you some examples. Okay, what could you do? So completeness of data. It's actually a really interesting problem, right? How, given a CSV file, how do you know how complete it is? You can count null values. You need to recognize the null values first, right? They don't always appear in the same way, but okay, you can count them. But how do you know it's complete in the number of rows, right? Is all the data there? How do you recognize that? It's an important question, right? And also the number of columns. Are all the columns present that I need, right? So how do you do it? Well, you could just give absolute counts, right? So say there are 100 rows. That's my completeness, right? Or you could say the data contains 50% of what it should contain, let's see, right? So my example is always, let's say you have a table with books, right? There are, 1 million books in that table, right? So how complete is it? Well, published, I think 1.5 billion books have been published. So 1 million divided by 1.5 billion, you have completeness, 0.001% or something. Okay, that's my completeness. But then you could go into the data. You could say, oh, these are all English books. Okay, so you can reduce the ground truth and say, this is a table about only English books, so actually my completeness is rather high, right? And then you could recognize, actually, these are only John Grisham books. It's not 1 million books, I guess, maybe 30 or so. And then you say, actually, the table is complete because these are all books by John Grisham, right? So the data can help you identify completeness, for instance, right? It's just one idea of how to go about it. Representativity. So how representative is my data? What does that even mean? So we have representativity, meaning its distribution represents the real world, which is usually what we want, but not always, right? Sometimes we want balance, right? So maybe the real world is unbalanced, and we don't want unbalanced training data, right? And then we have diversity, which is then the question is, do all possible combinations appear? How diverse is my data set? You know, is it all just, I don't know, male computer scientists and female biologists, or is it, you know, do we have other combinations as well, right? So how do you do that? I think this is an interesting computational problem, right? Which combinations are missing, right? Do we have a male nurse from South Australia in my data set, right? How diverse is it? And this is a very, you know, it's kind of a data mining challenge, right? It's not so much about defining data quality, it's about mining the data. It's a computationally interesting problem. One more, correctness, also kind of a traditional thing. Obviously, you have traditional error detection, outlier detection. What we've also done in the past in the data profiling area is we've mined business rules or dependencies that are true in the data, and then we find violations of those dependencies, right? Very, very easy and traditional stuff is zip code and city, right? We all know the zip code determines the city. I'm not sure if that's true in Australia, I'm assuming so, right? So if you know the zip code, you know the city, and you can easily detect errors there or violations of those dependencies, right? But it gets more complicated. It could say managers earn more money or a higher salary than their subordinates or so, right? And these are also kind of business rules that you could find and then validate, right? So again, an interesting problem. But then, of course, if you get to more difficult territory, how do we measure relevance? How do we measure understandability, et cetera, et cetera? And I think these are all really good research projects, and I think some of them are rather interdisciplinary, right? It's not, you can't just look at the data and hope to understand everything from it, right? You need, as I said, all these facets that I showed earlier. And that's not all. Last slide. There are further challenges in assessment. First of all, ambiguity. I mean, you've all already been wondering, what does added value even mean or so. So these definitions are by no means unambiguous, right? Everybody has a different feeling for what completeness actually is, what understandability means. Then, of course, explainability. When you say, okay, completeness is 0.95, you need to be able to explain this, right? You need to be able to say, how did you come about with that value, right? We need to be able to do it fast, right? Because I see a typical pipeline. So here's a CSV file. I dump it in there. I get a data quality assessment, you know, whatever my data quality is. And now I say, okay, I don't like this. Let me clean the data, or let me choose a subset of the data and then reassess, please. So I can't be waiting half a day for those results, right? And then compliance, right? So how do we integrate this assessment into the whole data governance process, right? So it's not just about a computer scientist with a server. You know, this has to be embedded. And then also scoring, right? What are the actual numbers? I've always been saying 0.7 and 0.9, right? But these are, I'm pulling them out of thin air, right? So how do you aggregate them, right? How do you aggregate the different, is it just a weighted average or something? I don't know, right? Well, we have to figure out how to give good scoring, right? To then also be able to compare different data sets. Right? This one is better than that one. To be able to do that, you need a good way of aggregating scores, right? So it's not just about all these different dimensions. There's a whole lot of systems problems to be solved as well. Okay. Good. So now I'm done, and I hope I've convinced you that data quality has a long tradition, but has, let's say, or there's the opportunity to put new life into this whole area, not just because it's important, but because there are also good research challenges involved, right? We looked at data preparation. This is like the let's say the very dirty end of data quality research, where you're fiddling around with the bits and bytes, and then all the way to things like correctness, and then finally data quality assessment. So with this, thank you for showing up. I'm around not just these days, but the next month, so I'm happy to have chats with you about these and any other topics. Thanks.
So this is for you, Felix, while I just moderate the questions. I think we have maybe a time for 1 or 2 questions, depending on how long it is. But I did notice, you know, that there was a few good questions around how do we know when the quality is good enough, right? Enough is the keyword. It's like, how long is a piece of string? And some more like the heuristic question, and, you know, about best practices, regulations, you know, carrot and stick. So, yeah, thanks for that really good questions during it.
Yes.
So any more questions from the floor? Yes.
Thank you for the nice presentation. I was wondering, your opinion about what's the relationship, in your opinion, between data quality assessment and the responsible AI user?
Responsible AI?
I saw many dimensions which
Yeah.
are already mentioned in the literature of responsible AI.
Yeah, yeah.
and the dimensions.
Yeah, I mean, this obviously this goes hand in hand, right? I've given this talk also in the, I think the workshop was called Guide, which was about responsible AI, right? And of course, as I said, this really goes hand in hand. You could argue data quality management is one measure of responsible AI, very simply put, right? And maybe these are, or assessment of these individual dimensions are key ingredients to handle AI responsibly, very simply put, right? Yeah. So I'm also aware of these, these data nutrition labels and these kind of things, right? And this is all that.